CBT Nuggets JNCIS Security Series System and Network Management. Well, in this nugget, we're going to cover four very important services that you're going to be using on a daily basis, really, to manage your network and security. Those are NTP Network Time Protocol, DNS Domain Name Service, SNMP Simple Network Management Protocol, and syslog. Let's check it out. Here's just a few reasons why Network Time Protocol is so important and to get your time from a NTP master server, preferably an atomic clock somewhere out there on the internet. It's for accurate logging of your administrative access. That's very important. For the accuracy of your public key infrastructure, if you're going to be using digital certificates, things like that. For troubleshooting, you need to know when the problem started. Okay, when did the problem start? Do you have an accurate date and timestamp? It's extremely important for things like forensics, computer forensics, and incident response and incident management. And of course, just tracking sessions, TCP sessions, and UDP sessions for ongoing monitoring. Okay, in the previous nugget, we looked at authentication of users who are going to be administering this SRX. Well, it's extremely important from an auditing standpoint, from a monitoring standpoint, and for, even forensics of our admins to make sure that we have a correct stamp log, date and timestamp. So NTP is one of those critical early services we have to enable on our SRX. Now, this is actually a pretty broad topic because you have lots of options. But in a nutshell, the main command is going to be set system and then NTP server. Now, what I would like to see you do before you do the server is to do what's called the boot server. Okay? So this is what we're going to use when the SRX is booting up. So you could use a different NTP server or service when you're booting up to get that initial clock synchronization, and then after that, as you're periodically going to be querying an NTP server, you could use a different server. Okay, so I could use, for example, maybe during the initial boot up process, I might want to use something local like 192.168.1.2. Maybe have an NTP server on a local workstation, management station, or server, and then I could go ahead and use the NTP server command and maybe even use something that's public. Like you could go out and use something on NIST. NIST has a bunch of servers out there like 92.226.123.117. I could use that out on the internet. Now, let me just talk about this real quick because you have several options. I'm just going to kind of roll back here and bring up my browser. One thing you can do on your SRX if you don't want to have a local NTP server is go up to NIST, and you can use one of their time servers, and you can see there's a wide variety of them here, different locations. New York, New Jersey, Pennsylvania, Maryland. I might go and choose one here in Chicago in my own time zone, maybe even closer in Carrollton, Texas. Now realize if you're going to use these, they are free. Okay, so they are a good option for you for your branch office. However, you have to be authenticated. They only support authenticated NTP requests, so you have to use a shared secret key, aka symmetric key crypto systems, encryption. So if you went up and you set this up, like for example earlier, if you saw in my command, let's just choose the one from Carrollton, okay, right here. If I went in here and said set system NTP server 92.226.123.117, it's not even going to respond, okay, unless it's set up with authentication. Now what I would do is, you can see I've got and I already did this command earlier, so let's do NTP authentication key, right? So what you have to do is you have to go through and jump through the hoops with NIST. You have to register with them, give them your information, and then they will send you a authentication key, and then you would just follow this up. You would just type in set system NTP authentication dash key and then put in that key that they send you. Okay, then you can use those servers. So that's one option that we can do. Or again, you can use one that's closer to you. Down here though, you can go click on this hyperlink, authenticated NTP description, to go get more information about how to get that authentication key from NIST and register with them. So that's one option. Okay, now what if you want to use a public server but you don't want to have to go through the authentication process? Maybe you just, for your own SRX in your lab environment, you just want to use something to synchronize to so you can get some practice doing that. Well, we have options there as well. What you can do is go up to ntp.org. So you can either use one of their servers, just put an IP address, or you could use a pool of servers. So what you might want to do here is you might want to go ahead and install an NTP server like from let's say again, I love to use free stuff, okay, especially for learning SRX and just getting ramped up and prepared for my exam. I don't want to spend any extra money that I don't have to, right? So what I could do is I could go and download this free NTP server. Let me show you. It's right here. It's Mindberg. Okay, Mindberg has a free NTP server. You just come in here and you download it for NTP for NT 2000, XP 2003, Vista, Windows 7. Even if it's Windows ME or something earlier than that, Windows 98, they've still got some solutions down here. You can go down here and go to their Windows Download Center, but hopefully you're not using anything that old, right? So you would just download this free NTP server. So let's say I'm going to do that here on this workstation. Okay, 192.168.1.2. Then let's bring this in. On the Start menu, you'll have a Mindberg folder, right? It'll add that to your Start menu. One of the things that you'll have on that, let me show you that real quick. You can see part of it. Okay, Mindberg Network Time Protocol, and then Edit NTP Configuration, right? So you'll want to do that. And so what we can do is we'll just come into this ntp.conf configuration file. This is really the key command here. And what we want to do is we want to just add our servers in here. So this is a round robin option for a pool of NTP servers. This is really a good way to go as opposed to like hard coding the IP address of an NTP server. The only time I really want to hard code an IP address of an NTP server here is if it's an internal server. Even with the NIST options, you're better off using a pool of servers at NIST and authenticating against those. If it's an internal NTP server, I could do that. So in my case, I could say my server's at 192.168.1.2. Actually, what I'm going to be using here is the Mindberg server, right? And then the Mindberg server is configured according to what we saw on the website. For example, bring that up again. What we saw that is up on the ntp.org website. So it showed us that if you want to use a pool of servers, just add this configuration here to your ntp.conf file, configuration file. Or I could even get down here and get more granular and just do the United States. And I could add these entries for the US. So you have lots of options. Are there other NTP servers out there? Of course, there's all types of different options out there. You can create a whole hierarchy, but we're talking about a branch office, remote office, small office solution here. So you're not going to have some elaborate hierarchy of NTP servers at the branch office that's using the SRX, okay? So if you want to use authentication, I would recommend going with the NIST option and go and just follow through with their instructions and you register with them and get their shared secret key and of course set system NTP authentication key. And then you could come through and you could add the IP address, or if it's a pool, they'll have other instructions for how to connect to a pool. Okay, so I restarted that service, which is running on 168.1.2. Okay, now like I said, I can set up, I would probably first do the NTP boot server command, 192.168.1.2, and then we'll do the same command, but this time we'll just do server. And we also want to go ahead and set the time zone. So we'll set the system time zone. And there's a bunch of options here, by the way. Okay, so we'll scroll down. I'm going to go ahead and use my time zone, which is America, Chicago. So that's going to be my time zone. This is hard to autofill because there's so many options there, so kind of have to go ahead and type it in there. Now, to use your new NTP server, in operational mode, we will set the date NTP, and I would highly anticipate this being on the exam. Notice I'm in operational mode, not configuration mode, okay? Set date NTP after I've gone ahead and set up my boot server for NTP, and a server for NTP, which could be different, okay, or the same one, and then I went ahead and set my time zone to America, Chicago. Okay, this is what you don't want to see, okay? No server suitable for synchronization found. So I got to go do some troubleshooting. Okay, what happened with my Mindberg NTP server was kind of, I don't know, it was running into some issues, so I went ahead and just did the next obvious thing, which was to go back to the ntp.org. I just searched for an open public server. I found one that was basically Texas A&M University, which isn't too far away from me. So I just set the system NTP server ntppub.tamu.edu. So you can go to ntp.org, you can find an open server, preferably something close to you, and there's one in every state or a bunch. There's a bunch here in Texas, so I just picked one that I was familiar with, Texas A&M, added that on there. And so then when I did the set date NTP command, this is what I want to see. Okay, I don't want to see the error that we saw here. Okay, this is the error that you don't want. That means you're not finding the server. What you do want to find, of course, is that you have found a step time server. Here's the IP address, by the way, of that particular server at Texas A&M University. Okay, so some other things you might want to look at that are commands that are going to give us some validation would be show system uptime. So we can see the current time, which is synchronized with the NTP server. Here we can see it's September 30th, 2012, and it's 1434 CDT. And let's take a look at show NTP status. We can see the version that we're using of our NTP server and the clock verifying our associations. Here's our reference ID right there. That's our NTP server at 128.194.254.9. That's a good one. And we can do show NTP associations. And here we go, ntp3.tamu.edu, and then we can see our other information there. Polling, delay, offset, jitter, all kind of good stuff. Okay, that is our NTP. Very important. Lots of options there for you. You can have your own free service if you want to spend the time to go through the Meinberg NTP. The challenge I was running into is I installed the Windows version, and the support documentation for the Meinberg NTP server is very Linux based, very Linux oriented. So all of the configuration troubleshooting information was basically for Linux installs. So I just said, forget it. I'll just go use one that's out here at the public. So if you want to use one that has authentication, there's some on that list, by the way, that I got this from that do demand authentication, and they have their own processes for getting their shared secret key. And again, you know the command to do that. Okay, so we've got NTP going now, synchronized SRX against this public server. We could also do it against a pool if you want to go through that option, which wouldn't be a bad thing to do either. And notice that, by the way, when we set this up, we were actually using, there's name resolution going on here, so DNS. So that's kind of a nice segue into our next configuration, which is configuring DNS. Now, obviously, we've already got DNS configured. Otherwise, I would not have been able to resolve ntppub.tamu.edu to an IP address. But that's the case. So let's go ahead and talk about configuring DNS on our SRX device. Okay, DNS was covered in pretty good detail in the JNCIA series. It's also covered in Network Plus. I'm not going to spend too much time here going over this. You know it stands for Domain Name System or Domain Naming System. It's a distributed hierarchical system. The goal is to convert host names or fully qualified domain names to IP addresses. DNS is divided into different sections or compartments known as zones, so we just can't get away from zones. They're everywhere. Every zone has named server or servers, and they respond to queries that belong to their zones. There's three main pieces. There's the DNS resolver, which basically is on the client side. When a user sends a request for a host name, the resolver sends a DNS query request to the name servers to request the host name's IP address. Then you have name servers. Name servers are basically the ones that process the query request that are received from the DNS resolver. And then it returns the IP address to the resolver. And then we have records in the database, resource records, different types of records. These are the data elements that define the basic schema and content of the domain name system. For example, the start of authority record and host record, aliases, name servers, mail servers. Okay, the DNS name servers will provide the host name IP address to the users. There's also a time to live field in the resource record, and that defines how long the DNS queries are cached, okay? And this is basically pushed down from the top. When the TTL value expires, the name server will send a fresh DNS query and update the cache. Now, one thing to be aware of beyond just DNS is the fact that your SRX may have to support in a large enterprise environment some type of integrity mechanism, okay, or DNSSEC. All Junos devices support the Domain Name Service Security Extension standard. Let's talk about that real quick. The DNSSEC is an extension of DNS. It provides authentication and integrity, okay? And it provides this verification by using a public key-based signature solution. With DNSSEC, all the resource records in the DNS will be signed with the private key of the zone owner. The resolver then uses the public key of the owner to validate the signature. The zone owner generates a private key to encrypt the hash of a set of resource records. This is actually what we call an HMAC, a hashed message authentication code, because the hash provides the integrity and the MAC provides the authentication. The private key is then stored in a special record called an RRSIG record, and the corresponding public key is stored in the DNS key record. The resolver will then use the public key to decrypt the RRSIG, and it compares the result with the hash of the resource record. That way it can verify that there's not been any alteration in transit. In similar fashion, the hash of the public DNS key is stored in a DS record in a parent zone. The zone owner generates a private key to encrypt the hash of the public key. The private key is stored in the RRSIG record. The resolver retrieves the DS record and its corresponding RRSIG and public key. With that public key, the resolver can decrypt the RRSIG record and then compare the result with the hash of the public DNS key to make sure it hasn't been altered in transit. This is what we call a chain of trust, and DNSSEC establishes a chain of trust between the resolver and the name servers in our hierarchy. Now, by default, DNSSEC is enabled on your SRX, but just keep in mind that it may be participating in this solution using the public and private RSA key pair that it was generated when you initialize it for the first time. Some things you have to do to make sure that DNS and DNSSEC can operate properly is just some basic configuration. Let's go take a look at that on the CLI. Now remember, we got our DNS servers because we're connected to our cable modem router, right? And so that's where we get our DNS settings from. If we do show config here, we can see those on our device. Here's the NTP server, by the way, that we from earlier. And we can see that our DNS servers, oops, I guess it's up here, farther up here, right there, name server. So we're getting these values from our service provider, in our case, service provider via our cable modem / router. But what if you wanted to configure this by default, or configure your own settings, your own DNS servers that reside in your DMZ or inside of your network, okay? We can do that by getting into configuration mode, and we would set the system name server command, and then put in the IP address. For example, we'll say it's 10.18.130.78 and 79. So you want to go ahead and put in there all of your name servers. Now we also want to have a domain name. Let me go ahead and do a commit confirmed here, because I don't want to save these values. I like what I've got going on. But we need to know this in case we're configuring this ourselves for our own environment. Okay, so we're going to do set system name server, and we said it was 10.18.130. We'll say 69, and then 70. These are our two DNS servers. Now, we also want to configure a domain name for our SRX. Now, we know what the FQDN, or the name of the device, is SRX210. So we put in the domain name, it will be SRX210 dot whatever the domain name is. So we're going to set the system domain name, hit the caps lock there, and we'll say it's going to be seclab.nuggetlab.lab. Okay, so this particular device here is srx210.seclab.nuggetlab.lab. You might also want to go ahead and configure a domain prefix to search to be able to resolve your local hosts without having to have fully qualified information. So we could say, let's set the system domain search, and we'll say, what was it? It was seclab.nuggetlab.lab. So for the JNCIS SEC exam, this is really all you have to know, just the basic setting the name servers, the domain name, and the search. Like I said, DNSSEC is enabled by default. It's a little bit beyond the scope of this particular course. You'll get deeper into that as you progress farther into Juniper. But that's our DNS configuration. If you're going to hard code it, again, we're going to go ahead and get our DNS service from our provider through our cable modem, which is probably the most likely solution that you're going to do in a remote office, branch office solution. Okay, next I want to talk about a very important tool that's been around for a long time, and that's Simple Network Management Protocol, SNMP. Okay, the next thing we want to do is we want to send SNMP traps to an SNMP server. Now, the SNMP server is going to be, it's a whole different animal as far as configuration goes. It depends on your environment. At a branch office, remote office, most likely we're going to be sending SNMP traps or informs over the internet back to the headquarters. If you have an SNMP server locally, then it may be part of your network operating system management and reporting, maybe something from Computer Associates or HP or IBM or whatever. Usually SNMP is not just going to be under the realm of security or networking. It's usually an enterprise solution. So what I'm going to show you here is how to go ahead and do a simple configuration of SNMP on our SRX. And we're going to assume that our SNMP server is at 192.168.1.200. Okay, so it's on our management network at 1.200. So working under that, and I don't really want to commit this, so I'm going to do a commit confirmed. I'm going to give it a nice 15 minutes here. So the first thing we're going to do is we're going to set a name for this particular agent. Okay, so there's an SNMP agent running on this SRX. We want to give it a logical name. Okay, so I want to edit SNMP. So I need to be in that particular area. And I'm going to set the name SRX210. How's that? We need to give it a location. These are just, these are just obvious things we can add. Okay, we'll set the community. We'll do a description perhaps if we want to. Maybe a contact name for the SNMP administrator. We'll choose a version. We're going to go ahead and do our location. Okay, right here. Let's go ahead and do that. Set SNMP location. Actually, just set location. We're already in the edit SNMP area. Set location. We'll say we're in the Abilene branch. How about the contact, the admin contact? We'll say that the admin contact is going to be Michael Shannon. We'll say the community. That's important. That's kind of our group name. So we'll set the community, call it the management, using a capital M, the management community. And then how are we going to authorize? Okay, a couple of options here. We can do read only or read write. Now we're going to be using SNMP version 2C, which is the ubiquitous version. So we want to go with read only. Okay, that's the best case scenario. It's the more secure option. Okay, I'm not a big fan of SNMP. I'll just tell you right now. It's got tons of vulnerabilities, especially if you're not using version 3, and version 3 is not very common yet. So a read-write community is very dangerous because write means we could basically change pretty much anything on this Juniper SRX. So we're going to go for our authorization. We're going to say read only, and we need to say who are our clients. Okay, so we'll set the community of management, and we'll say our client, and the clients are basically the management stations that can poll this device. So if you have an out-of-band management network, you could put like a sub-network in there. Like I could say 192.168.1.64/27. And usually you want to create a sub-network in that case rather than saying /24 because you want to reduce the attack surface. So if you have, potential of 254 management stations, that's a pretty big area for malicious users to compromise. But you could do an individual device. So you could say, okay, it's 192.168.1.2, which is this workstation, /32. That's really reducing the attack surface down to one device that can poll the SRX, which is the way I'm going to do it. Now, the best practice for using the source of the SNMP traps or informs from this SRX is to use the loopback address. Well, I haven't set that yet, so let's set interface loopback 0, unit 0. I'm in the wrong. I have to get to the top here. set interfaces, loopback 0, unit 0, family, IP version 4, and then the address is, we'll say it's 1.1.1.1/32. So I'm going to give it a loopback address, and this will be the source. And definitely, on my devices, I would have loopback addresses of 1.1.1.1, 2.2.2.2, 3.3.3.3.4.4.4.4, however you want to do that. But I can identify this SRX based on this loopback address. So that's really a good way to do that. So I'm going to go ahead and set my loopback address. And now we want to get back to the SNMP area, edit SNMP. And now we're going to pretty much set the SNMP attributes, right? So I'm going to set, and this is all under an area called trap group, and you need to put in a little bit more than just trap dash because it's ambiguous. You can do trap group or trap options. This is what we call it in Junos, okay? A trap group. What is this trap group? Well, it's management. Now, what version do I want to do? The ubiquitous version is going to be 2. And if you choose 2, it's going to be basically 2C, okay? So I'm going to choose that as my version. Also, this uses UDP. I'll use the up arrow. This uses UDP port 162, and that's pretty much the default. You would only change that if the server was going to use something that was non-default, UDP 162. So we'll go ahead and go with that option. And then what categories in the management information base of information are we going to send in traps to the server? So if you go up here and we choose set trap group management categories, these are the categories that we can send: chassis information, configuration notifications, link up down information, remote operations, RMON alarms, routing information, services, startup. That would be a good one, okay? So some of the things I probably would do here, just out of the box, I would definitely probably do the startup. I'd want to get that to my SNMP server. I would probably want to do authentication because I want to find out if I've got, some failed logins happening. Might be a brute force attack. Also, services. And I'm just wondering if there's anything other than services. Just services. Okay, so services. And then how about my link? My link information, right? So we'll up arrow and do link. Okay. As I said, I need to send these traps to a server at 192.168.1.200. That's the SNMP monitoring station in my environment. So I need to set the trap group management and then its targets, and then the IP address with no CIDR representation. So 192.168.1.200. Okay, that's the target. Now that's the configuration, and so I can just do a show command here, and I can see the name, the location, the contact. My community is called management. The authorization is read only, not read write. And then I've got this one client that can pull the SRX. We could say this is an out-of-band management, this is a in-band server if you want to look at it that way. So this typically would probably be the same IP address, but this is the important stuff, version 2C, the UDP port 162, and the categories, okay? So these are the subsets of the SNMP MIB that I'm going to be sending information to this server at 1.200, authentication, link, startup, and services categories. So that's the configuration. That's SNMP. Again, most of the configuration for this is done on the SNMP server side. That's well beyond the scope of this exam, and the options are almost unlimited. Okay, there's some free SNMP tools out there, quite a few. You can go to maybe download.com or some of the other places and play around with them. Just be careful downloading some of the free services like the ones you'll find on the internet. Now, we can view SNMP information locally with the trace options command. Let me do a run show config here, and we'll see, here's our NTP server. Here's our SNMP information right here that we just configured. Okay, all that good stuff. Notice this trace options here. I just configured this. And so I can actually go look at SNMP locally by doing a show log snmp.tr file. Okay, let me show you how I set that up. Actually, first of all, we'll do a run show log snmp.tr, and we can see our local, here's our snmp log, okay? And so this is the most recent information here, snmp information. So how did I set that up? Well, let me show you. I did a set snmp and I did the trace options, and I said the file snmp.tr, that's my trace file. I can set the size of it, for example. If I can go up here, I can say the file size, and you'd put, let's say, if you wanted it in megabytes, you could say, let's say 5M, and then we could say how many files do I want to create, and then rotate those out, right? So I could say file, and then files, and then the maximum number of trace files from 2 to 1000. So we'll say, let's go ahead and make it 10. And then this is interesting, who do you want to be able to read this? Okay, so don't allow any user to read the log file, or allow any user to read the log file. So that would be world readable. So add that in there. And then finally, what flags do we want? So we'll say we want everything. So we'll flag all. Okay, so that's how you can create, use the trace options. Then you can just do a run show, or you can exit. I don't want to commit those, and I can do a show log, and then that snmp.tr file. I can look at my log locally. Okay, excellent. I used to use Kiwi, K-I-W-I, okay, K-I-W-I, Kiwi syslog server, until it was purchased by SolarWinds. Now, SolarWinds has some great tools, but I recently tried to go get the Kiwi server from SolarWinds and install it, and it was quite a headache. There's a ton of extra code that SolarWinds dumps on there if you're going to use their free Kiwi syslog server. I'm not going to call it spyware, but you're connected to their servers. It's got adware. It's a mess, and you have to jump through a bunch of hoops. You have to give them a bunch of information, personal information, to register that free Kiwi syslog server. So I don't like that. Here's what I'll recommend to you: go to YouTube. Let me bring up a YouTube window here. Okay, this is part of a YouTube video. If you would simply go to YouTube and search for Ubuntu syslog server, this is a great way to go to have a syslog server and even a DHCP server, because there's one that's included in Linux Ubuntu, and that's a free download. You can even install it for your purposes of learning and for labs. If you want to go full bore and send syslog messages from your SRX, then you can use the free syslog daemon in Ubuntu, and Ubuntu is a free build. You could install it into a VMware player, or you could install it into Oracle VM VirtualBox is another good example. So just some free VMware tool, install Ubuntu into that and use that as your syslog server. It could even be your SNMP server if you find the right software. So you'll find several YouTube videos up there that walk you through the process of setting up this syslog daemon on Ubuntu. And then I'll show you the steps. We'll assume that our Ubuntu server is at 1.201. Okay, and by the way, you need to make sure that the Ubuntu system has a hard-coded IP address, not getting a DHCP address. So I want to hard-code it as 1.201. Okay. And then just walk through the steps they show you up on YouTube and set up that syslog server. It's totally free. It works great. And if you know Linux, if you're familiar with Linux, it's a no-brainer, okay? And you won't have to worry about all the extra stuff that comes with some of those other quote-unquote shareware, freeware syslog servers. Now, by the way, I can show my logs internally. Okay, so I'm in configuration mode, so I need to do the run command, but I can do run show log followed by, there's a bunch of logs here, by the way, question mark, system logs. You can see, inventory logs. These are the system logs here. So I could do run show log messages, and I can see here is some information. What I'm seeing here is basically the root logged in and rolled back my system. Okay, so that's one of the things that just shows it. So you can show your syslog messages here, and you can see the logs that are created. You know, messages dot 0, dot 1, dot 2. You can also do date and timestamps on there and the size. So, you know, if you want to look at system messages or system logs, you can certainly do that at any time. If you want to have a remote log server, and let me clear the screen, we would need to set the system, and it's the syslog server. Okay, so it would be the host address of your Ubuntu workstation or virtual machine with the hard-coded IP address of 192.168.1.201, right? So you jump through those particular steps. We could even put in there, you know, what is the source IP address? Okay, so do we want to use the source IP address of one of the interfaces on this SRX? So do I want to put 192.168.1.1? Maybe I want to put in my loopback as my source address. That's always very important, okay, to know what the source address is. You know, the date and timestamps are obviously important. That's why NTP is important. But another reason to use loopback addresses, besides with our dynamic routing protocols, is to help identify systems in a uniform fashion. And remember, loopback addresses never go down. They never fail, right? When you use a logical address tied to a physical port, well, there can be problems. And if you want to basically log anything, you could just say at this point any, and that'll give you all of your logging information. And probably early on, you want to log everything and then start looking at how you can start trimming it down. Okay, so that's the configuration. Again, we can look at logs locally, syslog information locally. We already got a glimpse of that, and then we can easily point to a syslog server. Okay, usually the setting up of the filtering and the setting up of the facilities and all those things are done over on the syslog server, either through a graphical interface, or if it's in Ubuntu, you'll be doing it in the console there. Okay, so that is our configuration. Let me use the back arrow so we can see the whole command there. Right, set system syslog host followed by the IP address, and then we're sourcing it from the SRX's loopback address, and we're basically saying everything, any. Okay, we'll do the filtering over on the other side. Now let's do an edit system syslog, and let's do a show command from within this area. And you can see, by the way, these are the defaults. This is actually the one I set up. You can see that any emergency. So these are the default settings that are part of the factory configuration. And basically, it's going to trim it down a little bit. The reason why this is going to be trimmed by default is because when we showed you earlier the show log messages to see the internal logs, you don't want those things filling up right away. So we're really just getting the emergency, critical, authorization information, and any errors in the interactive commands. Okay, by default. But when you're sending it to a remote server at 1.201, you might want to go ahead and say any at that point, because we aren't concerned with filling up those syslog file server. We can handle that on the syslog server side. All right. Okay, in this CPT Nugget of the JNCIS Security Series, we looked at system and network management of our SRX, focusing on 4 services: Network Time Protocol, Domain Name Service, SNMP, and syslog. I hope this CPT Nugget has been informative for you. I want to thank you for viewing.